All right, guys, so for the first part of the experiment, we're looking at the inclined plane, specifically trying to figure out the angle for the coefficient of static friction. And so the setup is pretty simple. We have our board here, right? We have our box or object on top of it. We have our rack where we can essentially adjust the angle of the board, which you'll see in a second, right? And so traditionally what we would do, you kind of clean the board, make sure it's nice and smooth. And then all you're doing is you're going to slowly introduce an increase in that angle until you notice the board start falling, right? And as soon as it starts falling, you're going to measure with the protractor the angle between the board and this table here, right? And you did that trial 4 more times, right? You move it up, start sliding, right? The second part we're doing is measuring the angle that's associated with the coefficient of kinetic friction, right? And so in the notes I mentioned that we're going to be starting at a lower angle, right? We're going to increase with slower increments. But since kinetic friction, right, involves the movement of the box, what we're going to do, rather than just move this box or this board upwards to see when the box slides down, we're going to actually introduce an external force, right? So let's say we start here. We're going to tap the back of it, just introduce an external force. And when that's not ready, we'll move it up, do the same thing. And as the box slowly starts moving with constant velocity, that's how you know you've hit the correct angle, right? So you can slide. All right, you measure that angle, and we measured that 4 times for 4 different trials. So the next part of the experiment was measuring the force directly applied when moving a box on a horizontal plane. And through that, we can figure out the force for the static friction and the kinetic frictional cases, right? So here, we have laid our board horizontally. We have put our box on top of it, right? And using this spring scale, right, we'll take a close look. This measures newtons, right? So this thing actually measures the force that's being applied. All we would do is hook this on here, right? And for the kinetic frictional case, right, we should see a huge peak and level out at a constant value for force. For the static case, however, it's gonna be that maximum value just before the box starts moving. So let's see if we can get this in video, right? So we're gonna pull, right? Pull the box, make sure that glare's out of the way. And that right there is the maximum value. You guys see how it just peaked just before. We're gonna stop and do it again so you can see. Go real slow, you should see it. Last time, peaks, and then it starts moving, right? So you're just measuring that force directly, right? You're gonna do that 3 times, right? And they're gonna change the mass, right? Based on the notes, that box right there weighs 0.209 kilograms, and then you would just continuously add weight or mass to that and do the same thing 3 different times, right? Hence the box or the tables being so large, right? You're just doing the same experiment over and over and over at different values for your mass.